Hi guys, in this video we'll be talking about the problem of the day from Geeks for Geeks on 6th of January. The problem's name is shortest prime path, and the problem states that you are given two 4-digit prime numbers num1 and num2. Find the distance of the shortest path from num1 to num2 that can be attained by altering only one single digit at a time. Every number obtained after changing a digit should be a 4-digit prime number as well, with no leading zeros. Then they have given us an example. So for example, if it's 1033 and 8179, then we require a total number of 6 iterations for them, because in a single iteration I can only change one digit. So for example, in first iteration I change 0 to 7, and we'll also have to confirm that this particular number that we are obtaining, that is 1733 in this particular case, this also needs to be a prime number. Then from 1733 we can obtain 3733 by changing 1 to 3, then so on and so forth till the time we have to obtain the num2 digit. Once we obtain that, we have to return the number of iterations that were required in order to produce this digit. In the second example, since both num1 and num2 are same, then we will just return 0, because no iterations are required or no operations are required and the two numbers are same. Then they have provided us with the constraints. So they have told the time complexity to be n log n and the expected auxiliary space complexity to be order of n, but I find it really confusing because nowhere in the question have they mentioned what's n over here. So it's like they have given us an ambiguous term and the complexity should be order of n log n. So I struggled it with for some time. I was trying to find out what they exactly mean by n log n over here, but since I don't know, and no one can predict what they mean by it, so I'm simply gonna do a BFS solution for this, which is pretty intuitive as well and pretty neat code. Also, I've tried that solution and that works on the test cases, so probably it should be the right solution. So with that, let's get started. So what they're asking us is that they'll be giving us two numbers. So let's say this is number 1, this is num2. Now num1 and num2 are 4-digit prime numbers, and let's say I'm converting num1 to another number by changing any one of the digit. Let's say I'm changing the digit at the first index. This is the 0th index, first index, second index, third index. So then the number hence created should also be a prime number. So firstly, I'll definitely have to have a function for a primality test. So I have to check if it's prime or not. It can be easily checked in order of root n by when I'm saying n over here, so I mean the actual number. So for example, the number is 100 over here, or number is 1000 over here, then in root 1000 I can find whether it's prime or not. So what we can do, so let's think of this particular problem in terms of graph. So let's say the num1 is actually a node. In one operation we can make it to, let's say, x, so we can change any of one digits from it and we can convert it into x. Then let's say x is another node. Similarly, we can perform some operation on it and convert it to y. From num1 itself we can convert it to z, and many number of nodes would be there in the entire graph. But at the end we need to tell that at what after how many operations when we able to convert it into num2. So it's possible that z converts into num2, or let's say it converts into a, it converts to b, then it converts into num2. So we have to tell the minimum number of operations. Because we have to tell the minimum number of operations, so what I can do is I can do a level order traversal for this. So in each level I can do one operation. So for example, from num1 is a node at level 0, so for num1 we need 0 operations. Then I can say I can convert num1 to a, b, c and d. For this I'll be needing one operation. I can further convert a, b, c, d to, let's say, g, h, I. This can convert to j, k, l. All of these nodes would need two operations. For what I mean by two operation is that in order to convert from num1 to these numbers, I need a total of two operations, so on and so forth. At the end, what we want is that sum of this node converts to num2. So a very intuitive approach is to use the BFS, because in BFS we do a level order traversal, and that's exactly what we want over here. Also we need a function for primality test. Let's call it is prime. So the is prime number takes integer I, and then it iterates over I is equal to 2, because 1 is neither prime nor composite. So and it actually divides everything, so we don't start with 1 itself, we start with 2 until the time I into I is less than n. So let's call it n actually. Okay, so I plus plus, it should be less than equal to. So basically we are checking till the time my number or the divisor is less than the square root of that number, less than or equal to the square root of that number. If n is divisible by I or its modulus is 0, then I can return 0 because it's a divisor. Then if it has a divisor, then it's not prime, or I return 1 over here. So that's a simple function from for primality test. So that's the basic. I won't be going much deep into that. After that I can take a q and I can push the num1 into that. So once my num1 is pushed, I can start iterating over that q dot size, or till the time that q is not empty. So what I can say is, since I'm doing a level roller traversal, I want to traverse all the nodes in a single iteration. So I can say that all the nodes are also present in the queue at that particular point in time. So the size of the queue is q dot size, and I'll be performing these operations on all the queues. So I'll be going through I'll be performing the operation on all the nodes at that particular level. So I'll be going through all the nodes, and the size of the number of nodes can be denoted by size itself. So I'll be performing this operation on all the sides. Now what kind of operation would I want to perform? So firstly I'll take out the number that would be present at the front of my queue. Then I'll change individual digits. Now how would I do that? There's a simple mathematical way to do it. I'll explain that in the code itself. Once I've changed the digit, let's say I'll obtain another number, let's call it temp. So I obtain temp from it. Then in temp I have to check whether temp is prime. I can check that from the primality function I had made above, and if it is prime, it should not. And if I have seen it earlier, have I seen temp? If I have seen it earlier, then I won't be pushing it on in my queue. Also, temp should be greater than 1000. The reason for this is that they have explicitly mentioned that there should not be any leading zeros, and that should be a 4-digit number. So 4-digit minimum number is actually 1000, but 1000 itself isn't prime. So let's say we are going for any number that is above 1000. If that's the case, then we'll push it onto the queue. Also, once I'm out of this inner loop that actually started over here, so I'll have to have a variable, let's call it levels. So levels define at which level we are, and let's increment it over here, levels plus plus. Also here I'm getting the num. So if the number is equal to num2, that is the final or the target num we want, then we can directly return the number of levels, as the number of levels denote the number of operations we need. So with that, I think this logic is clear. This question wasn't all about BFS, so I explained BFS in brief. I have actually explained BFS in detail in some of the videos. I'll try to put it in the I button above, so you can check the I button above if you want, info button above, for detailed explanation on BFS. Or if you want another video on BFS, please let me know in the comment section below. With that, let's get to the code. So in the code we are doing the same thing. We are having unordered set seen. So this is basically the set that actually tells me that whether a node has been seen or not. So after that, we are taking a queue and pushing the num1 onto the queue. We are also making the scene of num1 like we are pushing num1 into the queue into this unordered set we made, so that we know that num1 has already been processed. After that, initializing levels equal to 0, then going through all the elements in that particular queue, taking the size because we want to process all nodes at the level in this iteration. After that, I'll be taking the number and then I'll be popping it out from the queue. If the number is equal to num2, if it's equal to the target number that we want, then we can simply print out the levels, or we can simply return the levels. If that is not the case, then I'm iterating from 0 to 4. Now what 0 to 4 over here means is that is it at the first place. So when we talk about numbers, we can say that what's the first place for 3124? It's actually 4. What's the 10th place for 3124? It's 2. What's the third place? It's 1. Or the thousandth place, what's the 10,000 place? What's the 100 place? It's 1. What's the 1000 place? It's 3000, right? So that's what I'm trying to do from with I. So when I is 1, basically I'm pointing to 4. When I is 0, I'm pointing to 4. When I is 1, I'm pointing to 2. When I is 3, I'm pointing to. When I is 2, I'm pointing to 1. And when I is 3, I'm pointing to 3 over here. So I think that's simple. And after that, I'm taking a factor. So the reason I'm taking a factor is that I'm not converting this the number I have into a string, and in order to iterate over a number without converting it into a string, I want an equivalent number, right? So what I'll be doing is that at the first iteration, as I said, when I is equal to 0, I'll be pointing to 4. So for that, and when I is equal to 1, I'll be pointing to 2. So when I is equal to 1, what I'll do is power of 10 comma 1. So that will give me 10, right? So automatically this number is of this particular order. If it doesn't make sense, don't worry, the next operation would definitely make more sense to you. Then I'm taking a temp number that is equivalent to num, and then what I'm doing is that temp minus equal to factor. So factor in case of 3124 was 10. I'm multiplying it by temp divided by factor modulus 10. So what it does is that 3, for example, the number was 3124 and the factor is 10 over here, so it will divide it by 10. It will give me a number 312. I'll take a modulus by 10. So modulus by 10 would then give me 2, because 312 modulus 10 is 2. So that's exactly what I wanted. And now my factor at the end is also 10. So I'll get 20. Now if I subtract 20 from 3124, I'll get 3104. In other words, I can say that I removed the element at the first location. So the initial element number I had was 3124. Now I have 3104. So I removed the element at the first location. Cool. After that, since in temp the element at the first location has been removed, now in in this particular place, in the first place itself, I can put 0, 1, 2, 3 up to 9. So I'll check. This is the way I'm putting it. So factor is for this particular example is still 10. So what I'll say is that factor into 0 in the first iteration, factor into 1, factor into 2. So let's say in the sixth iteration it would be factor into 6. So I'll be having 60. So I'll add 60 onto it. I'll get 3164. So that's similar to saying that I changed. So this was the initial number. Now I'm having 3164. So I'll say that I changed the first factor from 2 to 6. Pretty easy maths, but when you do something like this, it becomes more fun and the code becomes simpler, and you can even code it faster. So this is always recommended, that until and unless it's not really necessary to convert the things into strings and proceed thereon, try to do it in this manner. The code is faster, it's better, it's more readable. So with that, what I'm doing is that if the number needs to be greater than 1000 and it should not already have been processed. If that's the case, just check for the primality. So the primality test has been done in the same manner that I had discussed earlier. So if all of these conditions hold, then push it onto the queue and then insert that particular element into the processed list. And now we have to subtract back the value we had initially added. So initially we had added 60 into it in our example. I'll subtract back 60 from 3164, and I'll be again left with 3164. I'll be again left with 3104. Yeah, that's it. Then I'll increase my levels at the end. Also, I'm returning a -1 over here because they had not mentioned that what should we return if this particular sequence is not formable. So I'm assuming they wanted us to return a -1, or they would provide us such inputs that the answer is always achievable. With that, I'll try to submit this particular solution. The number of test cases are small, I guess. Oh, it's showing 145 out of 45. Great. Anyway, so this problem was now submitted. and we get a AC also. The time taken is 0.31 second. Yeah, that's it for this video. Let me know if you have any doubts or you want me to make videos on any other topic. Thanks a lot, guys.